Good morning and welcome to Water Canada's Blue Economy webinar series. My name is Corinne Lintz and I'm the content director here at Actual Media. I'll be your moderator for today's discussion where we'll be talking about PFAS. Right off the top, I would like to thank Ultra Proven Solutions for sponsoring today's webinar. All right, so let me show you around the Cribcast platform a little bit. By now, you've probably noticed a few people checking in on the right-hand side of your screen with the chat feature. Please say hello, let us know who you are and where you're from. Right above the chat, you'll see an Actual Media icon. If you click follow, you'll continue to be updated on our Blue Economy series as new webinars are announced. And down below, you'll see a variety of information. You can see how many people are signed into today's webinar. You'll see the polls feature where we encourage you to cast your votes. And you'll also see a little green button that links to the speakers' websites. You'll notice that changes intermittently, so be sure to check those out as well. And most importantly is the Ask a Question feature. Please don't be shy about becoming part of the conversation. We'll do our best to answer as many questions as possible throughout. And I'm looking at the attendee list here and I can see we have lots of familiar names. So welcome back. For those of you that are tuning in for your first Blue Economy webinar series, I strongly encourage that you visit Water Canada's events page where you can find recordings of all the webinars we've been doing over the last 18 months or so. We have a powerhouse panel of speakers lined up for you today, and we are running just a couple of minutes behind schedule, and I apologize for that. But before I introduce them, I would like to take a moment to acknowledge the many First Nations and Indigenous peoples of Canada as the original stewards of this great country. I'm in Toronto, which is located on the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples. We all share in the responsibility of our natural infrastructure, and there is much we can learn from the traditional knowledge of the land, water, and materials that allow us to build projects that benefit all Canadians. All right, so let's get started and meet today's experts. I am going to begin by inviting each of our panelists onto the screen. Once they're all on screen, I'll have each of them spend just a few minutes to introduce themselves, tell us a little bit about where they're from and what their role is, and of course, what perspective they bring to today's discussion. And you will see that they come from different categories in the industry and makes it a very interesting conversation. Our first panelist today is Lakshmi Begum from MTE Consultants. And we'll just give her a second. There she is. Welcome, Lakshmi.
Good morning, Corinne. Good morning, everyone.
Bharat Chandramuli, I think I said that wrong, but I apologize. Chandramuli, I believe, from SGS Canada. Welcome,
Hi,
Bharat.
everyone.
And then we have Faye De Leon from Canadian Environmental Law Association. Just give her a moment. There she is. Hello, Faye.
Hi, everyone.
We have a full panel today, so we're all going to get a little bit smaller on the screen here. Martin Bureau from Sanexon is up next. And then
hello, everyone.
Good morning. And then last but not least, we have Maureen Dooley from Regenesis. And there she, oh, look at that. We got everybody.
Hi, everyone.
Beautiful. It's a tricky thing some days to make this happen somehow. I don't know after all this time, but we did it. Awesome. All right, Lakshmi, will you lead us off with an introduction for yourself, who you are, where you're from, and what perspective you're bringing to the conversation today?
Thanks a lot, Corinne. Thank you for arranging this one. It's a very timely webinar. We all need this. So as you know, I am Lakshmi Begum, a senior project manager with MTA Consultant. So MTA Consultant, we have 5 different offices here in Ontario, and I'm in the Burlington office. So what we do, we are the consultant. So I'm personally a wastewater and biosolid treatment specialist. So we actually help different variety spectra of client, starting from the municipal client, who actually have the wastewater treatment plant and biosolid management facilities. Other than that, we can actually serve the government as well as institutional, commercial, as well as private client too. So our main focus is to treat the wastewater and biosolid, their handling, management, reuse, and the best disposal option, putting them back to the environment. So we take the wastewater, contaminated water, or with different pollutant, make them suitable and make them suitable for releasing back to the environment. Same here, the residual that come with from the wastewater, they are called biosolid or sludge. We make them suitable to going back to the environment, and also we're trying to reuse them for beneficial use. So my expertise here is how PFAS is going to affect our sector for wastewater and biosolid treatment. So if anyone here wanted to know the current status and future direction, feel free to ask me the question. I'll try to answer my best with the most available information we have at present. Thank you.
Thank you so much, Lakshmi. Bharat, you're up next.
Absolutely. Hello, everyone. Bharat Chandramouli. I work with SGS. We're a large testing, inspection, and certification company all over the world, headquartered in Geneva. But in North America, we have 18 labs doing all kinds of environmental testing, and that is mostly the perspective I will bring to you today. We specialize in PFAS testing. We have multiple labs across North America that have been working on PFAS testing, measurement, uh, all kinds of issues related to sampling and analysis since I would say 2004 or so. I have been working on PFAS measurements since 2008. So I've been involved in the development, validation, troubleshooting of multiple ways to measure PFAS and all the things that can go wrong and go right. So look forward to sharing some of these perspectives with you today, especially as we look forward to what's going to happen in the next few years.
Thank you. Okay, Faye, over to you.
Yes, good morning, everyone. My name is Faye De Leon. I'm a researcher and a paralegal at the Canadian Environmental Law Association. I'm based in Toronto. We are a legal clinic. We're one of probably 70 legal clinics that gets its main funding from Legal Aid Ontario. We provide legal services to people of low income and communities that are considered disadvantaged. We do a host of we provide a host of services, which includes, of course, providing legal representation to those people who fit the criteria, financial criteria, to obtain the legal services. But we also have a complementary process by which we provide public legal education as well as doing law reform in support of people who are disadvantaged, purposely to increase access to the decision-making process, to create that voice of opportunity, to strengthen laws and regulations that are in place. Specifically, from my role as a researcher at the clinic, I've been here for over 20 years. I work a lot on chemicals policy at all levels of government, including international. So one of the things and that includes sitting on advisory committees that deals with these issues specifically. Now, I've been following the PFAS issue since probably mid 2000, when the federal government proposed its first action on the fluoropolymer chemicals, and have subsequently followed it through the international negotiations that have been happening, as well as the work we do on Great Lakes. So this is very close to my heart in terms of the work that needs to be done, and our attempt to engage in this conversation is to create more transparency and right to know for communities that may be affected by PFAS and don't know that they are. So that's basically the perspective I bring to the table.
Great. Thank you so much, Faye. Okay, Martin.
Hello, everyone. I'm Martin Bureau. I'm Vice President Innovation at Senexen, and I'm here to represent Ultra Solutions. In my role, we get to develop and commercialize the best solutions and the most cost-effective solutions for dealing with our most challenging environmental concerns, one of which being PFAS. I'll do a very quick introduction. We did our first PFAS remediation job in 2000, where we dealt with a ton of concentrated triple F spill on a military base. And since then, we've improved on our methods and came with probably is one of the best solutions in the world with dealing with high contamination, diversified contamination of PFAS streams, whether they come from industrial wastes, landfills, military base, airports, and so on. And that'll be my pleasure to talk about that and learn about all those great speakers that we have with me today. Thank you.
Thank you, Martin. All right, Maureen.
Hi. Good morning, everyone. Happy to participate. Thank you for inviting me. My name's Maureen Dooley. I'm with Regenesis, and I'm located in the Boston area. And Regenesis is a company that is based in the U.S., but we have offices in Europe, and we do a considerable amount of work in Canada. So the focus, or what I'm going to bring to the table, will be how can you think about addressing PFAS in situ? So we as a company focus on in situ remediation, and we have also been have approaches that can be utilized for in situ applications to address PFAS. And interesting, Martin was talking about his sites. Our first application was actually in Ontario and dates back to 2016 now. So anyway, I'm happy to answer any questions and look forward to participating with us with this great panel.
Great. Thank you so much, Maureen. All right, well, let's dive in. For many of us working in the water sector, I think PFAS has become a relatively common term, certainly for those of you who've been, since 2016, 2000. Like, that's crazy. It seems like a long time ago. But we're hearing about it in reference to drinking water, wastewater, biosolids. We're hearing about all these forever chemicals more and more frequently in mainstream media now. And I would hazard that the majority of our attendees today are probably a little bit more informed than mainstream. In the mainstream, we definitely have a water-focused audience. That being said, I think the best place to start is, what is PFAS even? I mean, it's a big question, but it's also a very little question. I imagine that all of you have probably spent a lot of time explaining to people, what is PFAS? Like, do you have a go-to explanation? I would love to hear what that benchmark explanation is. And then as we move forward in this conversation, we can get into the nitty-gritty. Who wants to tackle it and get like a practice? Go for it.
Yeah, I'll take that one, Corinne. So on behalf of everyone, I'll give a brief introduction. So PFAS, we can say par and polyfluoroalkyl substances. So they are actually man-made substance, and there is a huge group. The number is increasing every day. So it was initially we heard it's about over 5,000. Now it becomes 6,000, and some of the research are telling now it is about over 9,000. So this chemical actually started accidentally. They created this chemical around 1940. They started to be using since 1950 to 2000. They have been using unrestrictedly in lots of variety and lots of sector. So they have been using in so many products, say lubricant, our cosmetics, surfactants, industrial products. And the main one of the very heavy users are the industry, especially the firefighting foams, aqueous film forming foams. Those are the heavy users of these products. So as a result, they are ubiquitous in nature. They are everywhere. There's a recent study published that says even they have exceeded the planetary boundary. There is no place in our planet. There is no that we cannot find a single place that is not contaminated by PFAS. So saying that, and so around 2000, that concern about PFAS is increasing. We get to know that it's not just any chemical. It's a chemical that can cause different health and human different lots of human health effect. To start with, they are carcinogenic if there is a high volume. They can cause damage to our internal organs like kidney, liver. They can cause immune system damage and many more. So saying that, 2009, US EPA has put some advisory level for PFAS in drinking water. It was about 400 ppt and 200 ppt for PFOA and PFOS, two of the most commonly understood PFAS. And then again in 2016, they reduced it 70 ppt. And recently in 2022, June 15, they have reduced that level to for PFOA 0.004 ppt and PFOS 0.02 ppt. So you can see the concentration, how much it has reduced. Mm-hmm. And even the rainwater has more concentration than that. So for us, for our sector, for water, wastewater, and biosolid treatment specialist, we have to know how to make sure that level. And the thing is, there's a lot of challenge in that sector because the health effect is not yet clearly understood. We don't know what is the impact and how low is good enough for us. So that is also not clear. So we have to know about that. And just another last information I'll give at the end, that they found PFAS in human blood as well. In Canada, we have 98%, US, I guess 99% population have PFAS in the human blood, around 2 ppb. So saying that, I'll leave the other panelists to contribute.
All right. Well, that's a That's a fantastic explanation. Go ahead. I think Faye, you want to add something.
Yeah, no, I just wanted to add and emphasize, the importance of the health effects association, because they're not completely determined yet, but the associations are stronger and stronger every day as the studies show, particularly for women and children who may be exposed in different ways than the general public. So, you're concerned about that. And the other information that is starting to come up is its connection to COVID, right? The possible implications for the effectiveness of vaccines, for instance. So those are issues that are starting to emerge based on recent science and should not be overlooked. And as Lakshmi had said, I mean, these chemicals are persistent, very mobile in water. So that's why the concerns around drinking water sources is really critical. But overall, the fact that it's found everywhere in the world, particularly ending up in the north where you don't have those kind of sources of pollution happening, is a real concern. And that's why I think it's a timely discussion to have, understanding the constraints that we have in terms of the science, right? And explaining what PFAS is really all about.
That's actually a really good lead into my next question, which we're looking into how PFAS is harmful. But I'm hoping that each of you can kind of look at it from the different channels that you're coming at it from. So whether it's wastewater or certainly from the health aspects, and we'll go from there. Who would like to start on? Brett, you're nodding. I feel like you're ready to jump in.
Lakshmi set it up really well. It's the challenge with the PFAS again is the sheer number, and the fact that many of them meet that persistent bioaccumulative toxic criterion that tends to set alarm bells ringing, right? That persistence is where it all starts. Carbon fluorine bonds are almost impossible to break in nature. There's a bacteria or two people may have found, but overall does not happen. So you put a PFAS out in some form or other, it's going to live for a long time in the environment. Depending on structure, and again, this is where things get very complicated. Depending on the structure of the PFAS, your health effects may vary. The longer chain PFAS tend to stay around in humans much longer. They will tend to bioaccumulate in fish as well, which is why for a lot of people, especially people eating traditional meat-heavy diets or fish-heavy diets, their major source is not actually drinking water anymore. It is fish. Or meat or other kinds of even milk. So PFAS, PFOA, these longer chain PFAS, that's where a lot of this concern starts. So while the industry and while we've focused on alternative PFAS, shorter chain, different structures, putting oxygens in the middle, putting fewer fluorinated molecules in here or there, what that also has added is complexity. Now we have thousands of these PFAS. Biggest challenge with health effects is, of course, the traditional model of testing is test one, test the other one, test the next one, keep going. You cannot. There's not enough time, right, with PFAS. So big debate in the community is where do you stop? How do you do this? The traditional toxicology way, or treating PFAS as a class, as in we will regulate PFAS as one entity. Reduce consumption, reduce production, reduce use. Not a settled debate. And, Lakshmi started with the definition. Even the definition is not settled yet, right? The EPA has different definitions for PFAS than the OECD, and the definitions matter because then what you regulate depends on how you define. And I am not even got started on the measurement, right? That's another big challenge.
And if I may build on what you just said, due to that debate, and which is scientific, it's actually used by industry and others, governments, to not act. So right now, there are many industrial sites that need to be remediated, sources that go to the water table and groundwater, which we all drink. Remember, more than 75% of the American people take their water from groundwater. So it's coming from somewhere, and it's definitely not from the lake. So we've heard about those cases along the Chesapeake Bay or in Michigan, close to military airports. But you've got the same in Canada. Now, what's interesting is that Lakshmi alluded to the criteria of the US EPA. getting to lower than detection limits that we all have access to. But in Canada, we're still at 600 nanogram per liter. That's a million times higher than the limit. That's for PFOA, and that's almost a million times higher than the limit you referred to. So we really need to act now and act on point source uh, where it's the most cost effective to deal with. And I see Maureen nodding. In situ
I
approaches,
agree.
in situ approaches, or at
Yeah,
least
there's
at
a lot
site
of different
approaches.
ways
Yeah,
to
it's
do
very,
this.
very important.
Yeah,
So please
yeah,
go
and I
on.
think with Martine and I, you will may present different ways, but we need to put all of our resources together to figure out, which option makes sense. And there's a lot of different ways we can and need to address this. And I think one thing I agree with you on is that because of some of the uncertainty on the health advisories, there are a lot of folks sitting on the sidelines and have not even started their investigations. But I think the take home message is it's not going away. Like the forever chemicals not going away, neither are the regulators. And I think it's just a matter of time and how much. But I am curious, do you anticipate any changes in your health advisories in Canada? Because that is, relatively high compared to what's in the US right now.
Can,
Well,
can
we
I?
know for a fact that that Health Canada is seriously thinking about a totally different approach, a class approach, where they'll use the total organic fluorines or the
Mm.
top method precursors. I'm sure Bharat can speak about that more than me. But they have been slow in doing that. So they're
Yeah.
updating it as someone in the chat is mentioning.
Just to add to your discussion, that government of Canada is actually planning to produce a PFAS report that is due to come in next year, and they are taking class-based approach. In Canada, we have several guidelines regarding PFAS. One of them is CCME. They have both soil and groundwater quality guideline,
Yeah.
and also government of Canada has some Great Lake protection strategy, and they have one of the very crucial regulation that they actually came out in certain toxic substances regulation in 2012 for three PFAS compound, PFOA, PFOS, and LCPFCS. They actually restricted the use, resale, export, and production of these chemicals in Canada. And they actually further strengthened these laws in 2022 and further restricted the use of those chemicals. So
Can I offer?
they are taking action.
Can I offer two comments? One, with respects to the community level, you asked the question, why should we be concerned? Well, many of the communities that are affected by PFAS don't know that they are affected by PFAS,
Mm.
right? That information, unlike in the U.S., there hasn't been that disclosure element. And so as the problem grows worldwide, Canada is very much more silent on the issue. The commitment to do the state of the science, state of PFAS report was made last year in April 2021. Now that's
Yeah.
after they have already had regulations in place on the long chain versions of the PFAS. That's not bad, but certainly that doesn't answer the questions moving forward for the full class of PFAS. So that's a good move forward. But is it fast enough? I think we're already in a responsive, reactive perspective around these problems, as Martin had indicated. And for those communities who are impacted, the fact that they don't know they're impacted and the fact that they don't know they should be testing in the urban setting, how much testing is done to the drinking water sources is one issue. We know consumer products is a big source of that releases, right? And in addition to the industrial sources, but in the in the rural setting, where people are relying on well water, groundwater sources, they don't often test for those chemicals. They're probably hundreds of dollars just to do that test. So it's an issue around equity as well. And for those people who are, we've done case studies in terms of the communities that may have been impacted but got delayed, like didn't get the information until years later. And oftentimes the problem is that there's a division between the roles of the government. Federal government deals with assessments and management of chemicals generally, but the provincial government deals with drinking water sources. So, is that information getting down quick enough? Is it being responsive enough? I'm seeing a nod. And I think the answer is no. I think it's very reactive. So
definitely no.
But
we reached out to many Ministry of our Environment in Canada,
yes,
and they simply don't know about the issue at all because it's not on their radar. It's not.
So the other thing that I just want to say is the discussion so far has been the reactive mode, which is deal with the contamination that we're seeing. What we propose, and that's why we work on it, is we propose a more preventative approach, a more proactive approach, which means that you have to go up the pipe. Why are we having this problem? The consumer products is a good source to start. The regulations that are in place so far deals with some of it. It doesn't deal with all the thousands of chemicals that are left. The other issue is, so our regulatory reaction framework isn't fast enough, and we don't have an ability to say these chemicals should not be used, and if any replacements are being considered, you have to avoid similar chemicals. So those chemicals that have been taken off the market, well, guess what? The replacements have been the short chain version of those PFAS. So, something has to give in terms of the regulatory framework to create the accountability that needs to happen within Canada. So I'll leave it at that for now. But I think that perspective, is important, hasn't yet been shared.
Barrett, did you want to jump in there? I feel like I've seen some nodding, and I know the regulatory stuff is near and dear to your heart.
It is, and I think from our perspective, I think there is definitely that reactiveness we've noticed as well. And as part of the measurement community, we are we know where the samples are coming from, and we know what they're being used for. The difference between what we get from Canada and the US is stark. Canadian work is typically remediation focused in almost 100%. Specific sites, especially typically federal sites, not much else is going on in Canada. We do a lot of pre-regulatory monitoring, so we're helping, provincial governments, municipal governments, kind of understand the issue on a pre-regulatory, non-compliance level. In the US, it is all over the place, right? So much drinking water testing, so much well water testing, so much response litigation, just a lot of in addition to all this remediation site investigation that's going on. So for sure, the differences as you cross the border are very, they're stark, and it's just cultural, right? And what the drivers are in the US versus litigation and public focus, public attention and media attention versus what happens in Canada, where things tend to be a little more orderly, I would say. I've lived in both countries, so I experienced this both firsthand. But yeah, it's definitely interesting. That's all there is to say about that at this point in time.
But in the US, despite that, all regulatory pressures are still not in place. For example, landfills right now are not forced to treat their wastewater or their leachates going to the public-owned treatment plant, but many do. Many actually right now proactively, probably because they find their interest in showing that they're doing something beforehand, are dealing with it. And so as a community, we need to work with those opinion leaders or action leaders and publish pilot studies, feasibility demonstrations that come with the. I'm sorry, I'll be the capitalist on this panel. That comes with the cost aspect of it, because right now that criteria from the EPA at the 0.04 nanogram per liter is simply insane from a money perspective. It's totally undoable. So people will use that not to act again. So we need to come up with ways to show that you can address those issues at fractions of cents per gallon and even lower for heavily contaminated water and 1,000 less for potable water treatment. So these things need to happen before we can actually see action and sites remediated throughout North America and throughout the world.
I just add 2 points here. It's very interesting. Two things here. One is that the detection methodology. So detection of PFAS is very challenging. So EPA has come out with their 1633 methodology. That's actually single laboratory proven technology, not yet multi-laboratory verified. So that can actually detect PFAS in different matrices like soil, water, solid wastewater. So that is still under development, not yet 100% proven. As I said, single laboratory verified. Another thing is the cost. The cost is very high for detecting and testing those PFAS compound. So that will be a huge challenge on the utilities like water treatment, wastewater treatment, and biosolid facilities. And what Martin said, government grant will be definitely appreciated because it will be a huge challenge for the utilities and wastewater treatment plant and say biosolid handling facilities to carry those costs by themselves. So it will be really appreciated if government come out some grant. And US EPA is planning to have some drinking water regulation either by the end of this year or early next year about PFAS concentration. And we know that what US have, Canada usually followed. So I think the authorities should start thinking. And I think US recently they got about some $10 billion grant regarding PFAS, right? Maybe Martin and you can confirm
Yeah,
about
and
those grants.
absolutely.
Yeah.
I think since Lakshmi mentioned 1633, just a side note, it was developed where I was sitting.
Mhm.
Yeah. Okay.
And that method. So it's one of the interesting things, and I wanted to just spend this time giving a little measurement update as well, and fast accurately with reliability is key to regulation. You cannot regulate what you can measure. So on this target analysis, meaning looking for specific PFAS in everything other than drinking water, in the U.S., this is really what's holding up regulation at the moment. We know there are two different methods for drinking water PFAS measurement. They're both in the books, and so they can be used to regulate drinking water. But everything else, your biosolids, your landfill leachates, your groundwater testing, your soils that you're trying to understand, essentially, we're still waiting on the standard method. So, we got 1633 out to the EPA single validated last year, and they're working through the multi-lab process. Hopefully, we'll be done with the lab work by end of 2022. We're still, uncertain on that, but 2023 is when we think really these methods will get into promulgation to a point where it can be used for regulatory purposes, your MPDES permits, your biosolids testing, your landfills, and all of those things, because PFAS is in every one of those substances or matrices you're trying to measure. On PFAS as a class, which is measuring organic fluorine, for example, which is a proxy for PFAS. All PFAS are organic fluorine compounds by definition. The EPA, I think it was 3 months back, put out a new method called Method 1621, which measures PFAS in water. It's water only by organic fluorine combustion. You essentially take a sample, you put it on a carbon column, and then you burn the carbon, and you measure the fluorine that is coming off of that carbon. So it's a good proxy measurement for all of those other PFAS that you cannot measure by direct analysis. 1633 targets 40 PFAS. We're talking thousands and thousands of PFAS that we need to regulate. These kind of proxy measurements, these total measurements are key to making that happen. And at least on the US side of things, that is happening as well. And, on the Canadian side of things, all of these methods are directly applicable to the kind of samples we run because the same samples. So hopefully, as these methods in the EPA move forward, we will see those benefits for Canada as well.
May I offer two comments because we're kind of the focus around technicalities of measuring PFAS, and I think that's really, really important. But at the same time, the communities that are affected right now don't get the benefit of that testing at the moment, partly because of the cost, partly because of the regulatory limitations that we face, and the lack of knowledge, right, around these issues. And I think one should step back a little bit and figure out how do we push this process faster, quicker, um, to be more responsive. And I think you're going to see a lot more concerns by the communities, whether they come in the form of legal action in Canada or not. The first step is, you know, the roles of the federal and the provincial government around these issues is I think to some degree is a barrier, right? And until we start to share the data that is supposed to be accessible through open source data on monitoring of some of these facilities, whether they're military based, airports, or even drinking water data, um, the concerns by regular Canadians may not know to ask those questions. And I think one of the questions that come up for me is, why is there such a stark difference between Canada's drinking water guidelines to that of the U.S. and to that of the specific states? We, as CELA and with other NGOs, have submitted a petition to the Office of the Auditor General asking for that explanation. And there wasn't an adequate explanation to that. And in fact, when the assessments were done on the PFAS that have now been regulated, those weren't determined to be a concern to health at that time. Whether that's changed and it's shifting, I think it is. But at the same time, those guidelines haven't changed. Yes, there's movement to review those guidance documents, but it's not responsive enough, right? So why is there such a difference in those numbers? And then subsequent to that is what do we have to offer those folks who are concerned around their drinking water sources? And I think even the remediation technology that's available, like if you want to protect your water, your drinking water source, is a carbon filter enough? Is it too expensive for people? Who gets access to that kind of technology? And I think it has to be much more a fulsome, more whole. The approach has to be much more wholesome in terms of the life cycle of these chemicals. So 9,000 chemicals, we can't go chemical by chemical as the regulatory framework requires.
Let's avoid giving people some Brita filters because breakthrough will happen in a few weeks. So there's no point. I would love to hear Maureen talk about Regenesis' approach to fixing PFAS in situ.
I would love to do that too. I'm just going to interrupt really quick. We have a couple of questions for the audience, and one of those is exactly that. It's asking about the technologies. So, we've got some patiently waiting questions here. So, with the recommendation of a 0.004 parts per or PPT, so health advisory, the U.S. EPA for PFOA, is the suggestion that PFOA is more toxic than 2378 TCCD, and I recommend that you look at the question because that was not very clear on me asking it. It's a lot of numbers and letters. Does anyone on our panel want to tackle that?
What is the question?
Good.
If you click on the ask a question there, it's the first question. So with the recommendation of a 0.004 PPT health advisory for PFOA, is the suggestion that PFOA is more toxic than 2378 TCC. This question's been in here since we started, so I just want to address that, and then we're going to talk about the technologies. I'm dying to hear about that too.
I can perhaps answer that question. Hello, Terry. How are you doing? I know Terry. So, yeah, I mean, it definitely leads to that point, right? So, to translate that into non-chemistry speak, TCDD is dioxin. So, 2378 TCDD is the most toxic dioxin, that we know of, and that is one of those seminal persistent organic pollutants, extremely toxic. And yeah, we are regulating TCDD at this point in time at 15 parts per quadrillion. Important to note that the EPA health advisory that was put out here, 4 parts per quadrillion, is a it does not take into account costs or benefits or treatment technologies or possibilities to measure or remediate at those levels. All it is a calculation that is based on the standard toxicology assumptions, based on the most sensitive health tox endpoint that the EPA came up with, which is essentially immunological health endpoint. So reduced vaccine effectiveness, right? So that's the one we talked about earlier. Based on that is where you get to this, and all these assumptions made around how much water you're drinking, Is it lifetime exposure? No, I mean, so many different factors. It's hard to tell comparing apples and oranges here whether that's actually true. What is more toxic? What is less toxic? Because it's all about the assumptions, what endpoints are being used. So that's a tough one to actually answer yes or no. But that's really the context here. The EPA comes up with the most sensitive endpoint, has safety factors around those, and that's where you come up with that bottom line. This is where we think it is, and obviously major debate in the community on how accurate that is, how realistic that is too.
Thank you, Bharat.
Indeed.
Okay, go
I'll
ahead.
take the second question for the second how to
Okay,
treat.
well,
Go
Wow.
ahead.
no problem. I want to make sure we have time to talk about the technologies. I've been trying to leave the
Yeah,
last
let me
question.
jump
So let's
in,
do that.
and
Yeah,
then
please do.
I'll talk a little bit. I know Martine has some things to talk about, but brief here. You're talking about community, squeaky wheel, what I see in the States. The communities that make the most noise, guess what? That's the Air Force Base that gets treated. Those are the sources that get treated. Number two, these drinking water standards are crazy. I don't know how these municipalities are going to handle this. So what's starting to happen? We're looking at stormwater, they're going upstream. So people with sources, getting to Martine's point, that's going to be really critical. How do we deal with these sources, and how do we just not give people bottled water and a Brita filter in their house, and how can we eliminate this? So what does our company do in situ? So many of these PFAS chemicals are known to sorb to carbon. Okay, what we do in essence is we have a material that we can inject in situ to, in essence, stabilize. And that's not exactly right. And I can get into the technical stuff or, offline on this. But in essence, we're going to look at this as a risk management strategy. So if you have a lake or drinking water wells down gradient, and there's, say, a source, say you're coming off of an airport or an industrial location, what can I do to cut that off so it doesn't get into there? So what we can do in the very short term is we can apply this carbon in the ground and create a Brita filter underground. So what may have take say 30 days to move across a piece of ground, it will take 60 years. So that's what we're doing. So what we can do is reduce the risk, reduce the flow that goes into some of these really important receptors, and we can work quickly. It doesn't work for all, and we're working in groundwater. This is not something that's a drinking water wastewater system. This is for soil and impacted soil and groundwater. We can deal with certain concentration levels and certain flows. It's not ubiquitous, but there's certainly many sites that we can apply. And interestingly enough, the first application we had was sort of by accident at a site in Ontario where we found there were PFAS chemicals. And so we had applied the material, and so we're like 6 years out, and we have not seen any rebound. So that's very quickly the approach we have. I'll post some resources that you can go to, and then I know Martine has some alternate ways to address some of these PFAS materials.
Yeah, it's not necessarily alternative way. It's really complementary approaches.
Complementary is a better word, yes.
Because it's so complex and it varies
Yeah.
so much from site to site.
Yeah.
So risk assessment is part of the deal because we can't afford to treat all of those. So we really need to address source point where it hurts the most, depending on what's downstream, whether it's a village or a lake where people pump their water out. I'm not going to name the lake. There's a lake on the Canada-US border that has on the American side a very large landfill. And guess what? A city pumps its water out of that lake. And guess what? They've got PFAS in their water. So this is exactly how we need to address it. The source is extremely simple to deal with, whether it's an approach like Maureen referred to, or physical chemical and then capture. It's not even expensive to do that. And then you settle the question for a city that's 500,000 people. So in a large lake, so map those lakes, map those military bases, and assess the risk. And there you go. That's the way we're going to be able to address it. There's no other way, actually.
May I offer a comment, Corinne?
Yes.
Yeah, actually.
So, yeah, no, I think this is a really
Yeah.
important, point of elevating this notion of, what's possible now. And, Martin had indicated you can't do all of them, right? So I think, again, I'm going to stress it. You need to go back up the pipe and figure out why the sources are still coming. Even if you put regulations in place, we're going to have stockpiles still exist, right? You're going to have ongoing contamination. So you need to deal at the front end and why we need to reduce and take an approach around a class approach around PFAS. You don't want to be substituting one PFAS for another. You don't want to be doing that.
I really wanted to add here some point with what Faye said. Yeah,
Can I just finish? Yeah, and so I think that really is part of the conversation and thinking about it in terms of essentiality, in terms of use. That's the only time where if there's a PFAS that's required for a time limited time, that's where you need to focus your energy. But it's going to cost a lot of money, and at the same time, it's not just remediation money; it's health cost money that we don't take account, right? Mm-hmm. And while the association with health effects isn't always there, but it's already hinted and growing as the day goes by, that you can't forget about that. So communities that don't have that ability to access that support, it's unfair. So part of it is the regulatory framework has to be fixed.
Go ahead,
okay. Thank you. Yeah. So what I wanted to say, what Maureen said and Faye said, when the site is already contaminated, it's a lots of huge effort. When the PFAS is already in the lake, there's a lots of huge effort to clean those lake and the site. The best approach is to stop them right at the source. So like in Michigan, what they have done an industrial pretreatment program. They are putting treatment right at the industry, those are discharging PFAS. And that's industrial pretreatment program is very successful there. So you can put the treatment technology right at the industry, those are discharging the PFAS before they go out and contaminate the environment. That is the most effective way. The best way is that elimination or production of the compound itself. And the next second step is, before finding the alternative, we have to stop the compound coming out of the industry. So the approach is first is separate, concentrate, and destroy. And here I'll simply touch base some of the treatment technology available just to answer those questions for water, that we can use granular activated carbon, powder activated carbon, ion exchange, as well as membrane for water treatment. And there's a lots of biosolid treatment technologies. I'll just post the link there for your information. So I won't take much time. Go ahead.
No, we're coming close to 11 or 12 o'clock, but I think we are okay to go over by a couple of minutes since we had a little bit of a late start. So if anyone
jump in. Yeah, go ahead.
Go ahead.
I'll build on what Lakshmi just said. So those are the conventional technologies, and I don't mean to be presumptuous here, but when you have 1,000 ppt or less, reverse osmosis, membrane technologies, carbon or resin may do fine. But we're dealing today on a site in the States with a leachate that has close to 1 ppm of PFAS in it. So that's 200 million times more the reference of the EPA right now. And it has tons of organic matter, tons of metals, saline. So in it, those technologies won't work in situations like that. So I come back to Maureen, combination of approaches. It's a big equation that we can solve.
Yeah.
Though. Yeah.
Yeah, because I think the landfills are for us are particularly challenging because of the other organic matter that's in there that can swamp out us, and so that's where combined technologies make a lot of sense. Where another place, So I actually be interested to learn a little more about, because you're working at a lot of landfills, right, Martin?
Yeah, that's where we found the most. Let's say the people stuck with the most pressing sources of PFAS to deal with. they're kind of the. I went to the Global Waste Management Symposium last spring in Palm Spring, actually, and one of the vice president of one of the largest landfill managers in the states, I mean, put it so clearly that he needed to act like yesterday. Now, come to us if you have better solutions. Where they're gonna. I mean, they want it now. So there are responsible corporate entities that are no longer the enemies in that thing. I guess, and they want to act.
Yeah.
Yeah.
I agree that there are a number of them because they're also anticipating potential liability, whatever, and they want it to be looking forward. So I think they're evaluating technologies now. And I agree with you in that sense. And they are looking for solutions and cost-effective solutions because some of the things that have been out there. And that's why I think, putting our heads together and, what is the most critical path that we need to cut off? Where is our money best spent to have the most bang for the buck? And, and the other thing is it's only a matter of time before they go upstream and look for these sources. We've already seen that happen with some folks already where they needed to have an immediate response to cut it off before it got to the water systems.
And then we get to what Faye presented to us. I mean, it's really important, all that advocacy and lobbying, legal, protecting the people on how to act. It's crucial that we do. You're actually the driving force, Faye, and people that do your job for all of this to happen. We're only scientists here trying to come up with solutions.
Yeah, I agree with Martin that we are the engineer. So the contaminant should not leave the site. And the best way to deal is at the site, at the production, at the source. And that's the way, it's the most cost productive way we can deal with it.
Well, I'll offer the prevention approach, certainly at this stage. And one of the things that everyone was talking is this whole notion of life cycle is really critical. And you're dealing with the back end of it where the contamination's already existed, right? And you want to stop it from entering the environment. But we really do have to look up at the source in terms of design of products, for instance. There's this whole notion that consumer products, for instance, that have lots of PFAS in it, scopes of materials that may end up being recycled. We think about that in terms of the issue around circularity, right? Avoiding them at the front end will stop that tap from re-entering into the recycling stream even.
Totally.
And Bharat had mentioned, if you put this, like if you compare it to dioxins, for instance, there are fluorinated dioxins that will be produced if you have to treat these chemicals through incineration, right? We have gotten information that there is waste that contains PFAS coming into the Sarnia area for treatment. Well, we don't know about that because there's no informed consent that's required for that movement. It's not considered a hazardous waste. So there's places where we need to add focus so that we could actually deal with this problem in a more comprehensive way and cost effective and more particularly protecting the most vulnerable in the community.
And we have not addressed the huge issue of biosolids. Because cities right now are using those as surf fertilizer.
What do we do?
I was ready to answer any questions regarding biosolid because it's a very crucial thing for our sector. Because currently we are doing a lots of land application, and if there is a regulation on land application come out, that will hugely going to impact our sector. Because currently about 60% biosolid is land applied. And if there's a regulation that has to go to alternative ways, like for thermal treatment, I already shared the thermal treatment database with the audience that EPA has listed a list of technology that we can use to treat biosolid. So,
we'll have to deal with it because if we put our chocolate cake into the compost, like we do in Montreal.
I had no idea it had that much in there. That's crazy.
So the good news on the chocolate cake is that was a measurement error. The USDA, when they did their method, made a mistake
it was
in the
after
measurement.
all.
Yeah, and then when they went back and did the correct method,
sorry to cut you off, but it was published extensively and republished and republished. Like
So
amazing, yeah.
the retraction was not published extensively, but that was a complete mistake on their part. When they went back and tested it correctly, it had disappeared.
Oh my gosh.
So
This is an
still we
amazing
need scientists.
conversation. What I
Yeah.
would love to do, I feel like we could go on for hours. I feel like we're actually just warming up a little bit here, but I would love it if we can get some final thoughts from each of you. I want to make sure everyone has a chance to kind of leave our audience with a final thought. Certainly, in that, if you also have any recommendations, and I'm seeing lots of links going down here in the chat box, that's great. So, any recommendations to find more information, links, they're most welcome. Stats about chocolate cake icing is a little bit sad for me. I'm going to be honest on that one, but
That's the thing we remember.
I'm now going to have to go commiserate and try not to eat
Google
chocolate cake while,
Google
you
it,
know.
you'll find it.
Yeah. So, okay. So, Martin, why don't you, you're top left for me. So I'm just kind of working clockwise here. Some final thoughts on today's conversation. And you've already put some great information here, but let us know where else we can look for more information to learn about all this good stuff.
So my take home message is simple. Our government need to act now. They have to have mandatory limits that people, industry, and local government, like water utilities, can enforce. If there's no point in putting fractions of part per trillion, we're at the memory of water level at that point. It's almost homeopathic, and we won't be able to address it. So let's be realistic, and I'll pass on to Maureen if she's in the right order.
She is. She absolutely is in the right order.
And build on point source.
And I think the take-home message is, this is a challenge. A lot of people are thinking about it and working on it. But just some of the comments like Faye made, there are solutions that can be applied now that can help. Are they perfect? No. But there are things that can be done now to reduce the risk associated with some of these, critical exposure points in people. So under that.
All right, Lakshmi, you're next in my clock here.
Yeah. So what I'm thinking, my message will be mostly for these as an engineer, right? We are the one who try to look for the best applicable technology to treat the contaminant. So my message to the producer as well as the government will be ready. It will be a huge things in Canada within 2-3 years because it is coming. It will be coming. So we have to know how to treat either at the source or at the municipal level at the treatment plant. So be ready, be flexible, be ready to answer question to the public, have your plan accordingly. Start preparing yourself that you have to come up with technological solution. You have to answer to the public. There will be more and more concern and awareness. And as well as if you need any treatment technologies, there are available treatment technologies, both for water, wastewater, and biosolid. And there are like expertise available. Feel free to contact us. We can find out based on your available situation, current situation, we can give you the solution.
Beautiful.
But the best solution to stop them at the source, at the production level, at the industry level. If they're in the environment, there will be more increasing cost, more complication, more effort involved. So
perfect. And Faye, I'm going to hand over to you next. I know you had a 12 cutoff, and I feel like we're holding you up a little bit here, but thank you so much for hanging in.
No, thank you for the opportunity to participate in this. And the technical and the legal stuff is really interesting in this because there's dichotomies that we have to face in terms of limitations. However, the thing that I want to share with you folks is creating that opportunity for community discussion around those, particularly that are impacted by PFAS and don't know. Right. So first thing, you need to disclose that information in a much more open and transparent way to be accessible and to understand and to push for reform at the regulatory level. Otherwise, you won't have the engineers trying to design things in a way to be in compliance with those regulations. So I think the transparency issue, disclosure issue, and community-based discussions coupled with a notion of prevention at the front end of the process so that, you look at PFAS as a class approach, and it's time to kind of move away from them because we cannot be spending the next decades dealing with the chemicals that we already have in the marketplace.
Thank you. All right, Bharat, bring us home.
Yeah, absolutely. I think what can I add to all these amazing closing comments, right? But I think to echo what Faye said and what Lakshmi said as well, and others, that information and communication here are key. And I mean, I'm a chemist, but really, we're in the information industry, as it were. Our job is to provide good PFAS information to people looking to make decisions. So, just measure the sources, measure your exposure pathways. We need to be proactive about that, not reactive, and share that information with the communities involved quickly, proactively, um, you know, transparently. One thing that, especially in Canada, we're not very good with is source information. The US has the toxic release inventory. We don't really have anything similar to that Canada. So a lot of people are in the dark. I think that shedding that light with the information that all of these amazing scientists and engineers are providing to us on PFAS is important to share with the people who are actually affected PFAS. And then, of course, just they are persistent. They're going to be around for a long time. Prevention is the only way to stop the PFAS contamination issue in the future. What's happened in the past has happened in the past, but in the future, prevention is our only chance.
Thank you. Thank you to all of our panelists. This was incredibly informative. And as I say, I feel like we need a part two. And of course, thank you to all of you that stayed tuned with us all the way through. Our numbers are still amazing. Obviously, a really engaged audience today. But your interest and participation through the chat feature, questions, polls, all of that goes a really long way to make these online discussions feel like a really strong sense of community. Once again, thank you, Ultra Proven Solutions, for sponsoring today's webinar. We wouldn't be able to host important discussions like this one without industry support. So big thank yous on that. And thank you again for joining us today. Keep an eye peeled for future Water Canada webinars, and we will see you all next time. Have a great day, everyone, and thanks.
Thank
Thanks
you,
all.
everyone.
Bye.